x cubed, that means this is a cubic equation. And a cubic equation can have up to 3 roots. So even though a lot of students will instantly say x equals 5, because 5 cubed is 125, that's only one of the 3 roots, and today we're going to find all 3. So let's begin properly. The first thing we do is move everything to one side. So we take x cubed equals 125, and we rewrite it as x cubed minus 125 equals 0. Now notice what happens here. 125 is the same as 5 cubed, so we can replace 125 with 5 cubed, giving us x cubed minus 5 cubed equals 0. And the reason we can do this is because now our expression matches a very useful identity called the difference of cubes, which says that a cubed minus b cubed equals the quantity a minus b, multiplied by the quantity a squared, plus ab plus b squared. This is a formula worth memorizing because it shows up constantly in algebra. So let's apply it here. With a equal to x and b equal to 5, when we substitute into the formula, we get x minus 5, multiplied by the quantity x squared plus 5x plus 25 equals 0. Now pay attention to the simplification. Whenever we have a product of 2 expressions equal to 0, that means at least one of those expressions must itself be 0. So we're going to split this into 2 separate cases. The first case is x minus 5 equals 0, and the second case is x squared plus 5, x plus 25 equals 0. Let's take the first case. X minus 5 equals 0. And from the previous equation, we get x equals 5. So that gives us our first root. And this is the real number solution that most people find right away. Now let's move to the second case, because this is where the other 2 roots are hiding. We have x squared plus 5, x plus 25 equals 0. And since this is a quadratic equation, we're going to use the quadratic formula. But before that, let's identify our coefficients. A equals 1, b equals 5, and c equals 25. Now we calculate the discriminant, which tells us what kind of roots we're going to get. The discriminant is b squared minus 4. AC, so let's substitute. That's 5 squared minus 4, multiplied by 1 multiplied by 25. 5 squared is 25, and 4 multiplied by 1 multiplied by 25 is 100. So we get 25 minus 100, which equals negative 75. Now notice what happens here. Our discriminant is negative, and whenever the discriminant is negative, that tells us there are no real solutions for this part. Instead, we're going to get a pair of complex conjugate roots. So let's apply the quadratic formula. X equals negative b plus or minus the square root of the discriminant, all divided by 2a. Substituting our values, we get x equals negative 5 plus or minus the square root of negative 75, all divided by 2. Now let's simplify the square root of negative 75. The reason we can do this is by breaking negative 75 into factors. We can write it as 25 multiplied by 3 multiplied by negative 1. So the square root of negative 75 becomes the square root of 25 multiplied by the square root of 3 multiplied by the square root of negative 1. The square root of 25 is 5. The square root of negative 1 is defined as the imaginary unit I. So we're left with 5 multiplied by the square root of 3 multiplied by I. Now let's substitute that back into our formula. So x equals negative 5 plus or minus 5 square root of 3i, all divided by 2. And if we want to write this more clearly by separating the real part and the imaginary part, we get x equals negative 5 over 2 plus or minus 5 square root of 3 over 2 multiplied by I. So now we have our 2 complex roots. Let's write out the complete solution. Our first root is x equals 5. That's our real number solution. Our second root is x equals negative 5 over 2 plus 5 square root of 3 over 2 multiplied by I. And our third root is x equals negative 5 over 2 minus 5 square root of 3 over 2 multiplied by I. And notice these last 2 roots are complex conjugates of each other, which always happens. when you're working with real coefficients. So to wrap this up, if you only wrote x equals 5 as your final answer, you'd technically be correct but incomplete, because this is a cubic equation and it always has 3 roots. So showing the full factoring process using the difference of cubes identity and then solving the resulting quadratic with the discriminant is what demonstrates complete understanding. If this explanation helped you understand complex roots a little better, make sure to like this video